to, I'm gonna make you stand.
Just because it's your birthday don't mean you can break the rules.
Exactly.
I do this every day. You
Okay.
This is a special day.
So we are going to do optimization in this section. We have done optimization before, so this is not totally new stuff. It's just using some of those skills that we already have. So when we optimize, the first we have to figure out what we're trying to maximize or minimize, so we can have that as a variable. We don't want to deal with x's and y's in the same problem, so everything has to be in terms of one variable. Okay, we also need some idea of domain. What kind of answers are possible? If I get an answer, is it reasonable or not? Then we know maximums and minimums are just another word for the critical points. So we find those critical points and use those to answer our questions. So here is our first example. A farmer has 200 yards of fence to construct 3 sides of a rectangular pen. An existing long straight wall will form the 4th side. What dimensions will maximize the area of the pen? We have done a problem
I
with this.
literally know this problem.
Yeah. This might have been an extra credit problem that I
Yes.
gave you first semester.
Yes.
So, what would I do? Picture. So we have a wall that we're using for one side, and then we have a rectangular pin coming off of that.
This is as far as I got on that extra credit problem.
I even gave you hints on that one. Okay. Are we putting fence on every side? No. So I have fence here, I'm going to call that X. Fence here, I'm going to call this X. This side is different, so I'm going to call it Y for a moment. But I know that I only have 200 yards of fence. So what would I have to do?
2x plus y equals 200.
Yes.
Actually, this is what we do.
So that missing side, Y, is 200 minus 2x. Okay, so now everything is in terms of one variable. Then I want to maximize area. How do we find area? So in that case, this would be x times that gives me 200x minus 2x squared. Anytime I say to maximize or minimize, what am I going to do?
Critical points.
We need critical points. How do you find critical points? Derivative. If you look, I put blank slides next to these so you have a little extra room to work. So we need the derivative, which is
200 minus 4x.
and to find our critical points, we set our derivative equal to. So 200 equals 4x and x is 50. How do I know if this is reasonable or not? Basically, we know the sides can't be negative, right? So 50 is positive. If I plug it in here, 200 minus 2 times 50, that's still positive. If I had gotten like 500, would that have been reasonable? No, because then this side would have been negative. So 50 is an okay answer. So then answer the question, what dimensions will maximize the area
50 by 100.
Where'd you get the 100?
Yeah.
200 minus 2 times 50 is 100.
I thought you that was wrong.
No, no, it was correct.
Where'd you get that answer?
Just making sure you knew.
Well, that's my name.
All right. The next problem, I want you to read and see if you can set up the picture. And we have 2 inner divider fences, both parallel to the same side. So there's 2 more fences in here. All right, so all 4 of these are the same. So I could call all of those X. We're putting fence around all the sides, so what would I call these? Y for the moment. So what would I do then? So y is 500 minus 2x. All right, and then that was our work so that everything was in terms of one variable. Now I want to maximize area, so we need an equation for area. Area is just length times width, so x times y, but my y is 500 minus 2x. Then anytime I ask you to maximize, minimize, what do you do? So that's 500 minus 4x. We want that to equal 0. Divide by 4, and we get 125. Quick check, 125 is positive. It would make my y, if I plug in 125 here, you get 500 minus 2 times 125, which is 250, so that is an okay answer. And then I just wanted to know the maximum area. So how do you get the area? Yep, 125 times 250, or plug it into your area equation. Either way. And we get 31,250 square meters. Is that one okay? Any questions for me so far? Okay. Take a look at this one. Read for a second, see if you can draw a picture. So we're starting with a piece of metal, and we have its dimensions. Then what am I doing? Cutting out squares. Do you guys remember doing these last year?
No.
What did we buy last year?
Yes, we totally did.
What
Well,
class was this
okay.
for last year?
College algebra. Or not trig. College algebra, pre-calculus algebra we did.
Yeah, that's 2 years back.
Okay, well, close
No.
enough.
I don't remember that much. You were going.
Not the
Yeah.
entire time.
You were going the
were
entire
pretty
time
much
until
going.
like
Are you
the
guys
last.
going to hold it against me forever that I had a baby?
No,
Yeah.
no, I just don't remember
Okay.
much from it because it was also COVID time.
So, we take those squares out. Totally my fault. And then we make a box from it. So we're folding. I can put it
Or
in
you're
that.
getting caught.
Okay. So, when I fold this box, do I know how big my squares were?
No.
No. I just told you they were all the same. So that's like our x. So the height of this box is x, where that piece was removed. Okay, the total length was 8, but I took x off one end and x off the other. So now what is it?
X, 8 minus X.
8 minus 2x, because we took them off both ends.
Yeah.
Okay, my width was 5, but I took x off each end, so now it is. Alright, so we have everything in terms of one variable. I'm trying to maximize volume. How do you find volume? So, if I multiply. Can I FOIL and distribute my x at the same time? Okay, so we get 40x minus 10x minus 16x times an x, so minus 26x squared plus 4x. Now what do I do with this?
I'm gonna take out X.
Before that, derivative.
Oh, yeah.
Okay, so that would give me 40 minus 52x plus 12x squared. And I need this to equal 0. So what can we take out of all this? 4. Let's just divide by 4 on each side. And then I'm just going to flip this around. So it's 3x squared minus 13x plus 10 equals 0. What do we do now? So they need to multiply the 30, add the 13,
Is it,
add negative 13.
wouldn't it just be negative 10 and negative 3?
Mm-hmm.
Oh, you have to do Boxman because it's not.
Yeah. So if we set those equal to 0, we get 1 and 10/3. Okay, so the next question, are both of those possible? What do you think?
No,
Why?
because it makes negative sides.
Go back to your picture. If we plug in a 1, we have 1 by 3 by 6, that's fine. If we plug in a 10/3, what's 5 minus 2 times 10/3?
Like negative 1.
It's a negative. So that one's not an option. So then the question was, how should this be done? So the squares have 1 with sides. All right. So far, so good? Let's try to do just touch on this, maybe do one of these examples, and that'll probably be where I stop today. So talking about how this relates to business. We have talked before about the cost function, and we know the derivative of cost is marginal cost, right? So the marginal cost, I should say, is the derivative of the cost function. You might fill that in. All right, another situation, that tells us how the cost is changing, but we might also be concerned with profit and those types of things. So we have lowercase p of x is typically called the price function. It's what you should charge for something. That's sometimes called demand. So demand and price are the same thing. To get the revenue, you have to take x times p of x. Basically the number that you're selling times the price you sell them for. That gives you the revenue, or the amount of money you bring in. And if you're worried about how to maximize that or make the most out of it, then we're looking at marginal revenue, or the derivative. So the derivative tells us how this stuff is changing. Another situation in business is profit. Okay, you're not just concerned about how much money you're bringing in, you're concerned with how much profit you have. So they use capital P for profit. And profit is just revenue, the amount of money you bring in, minus cost, the amount of overhead you have. the amount of money you keep is what you bring in minus what you spend, okay? Marginal profit then is, of course, is the derivative. So if I ask you to maximize your profit, we are finding the derivative of our profit. So we're going to look at one scenario involving these today, and then we'll pick up with that tomorrow. Okay, so let's look at this. So, suppose the cost of publishing a book is $10,000 to set up the press, plus $8 for each book printed. Could you write a cost function right now, C of X? Assume it's linear.
Yeah, so like 10,000 plus 8x.
Mx plus c. Your slope is 8, that's your repeated cost, your 10,000 is a one-time thing. Okay, so x here is the number of books, the way we have it set up. The publisher sold 7,000 copies last year for $13 each. So if I write that as an order pair, my number of books was 7,000, and the cost, my y, was 13. Sales dropped to 5,000 copies this year when the price was raised to $15 per copy. Assume up to 10,000 copies can be printed in a single press run. How many copies should be printed and what should be the selling price to maximize the profit? Okay. Profit is revenue minus cost. So we have costs, we need to get revenue if we're going to figure out our profit. So let's look at this information. This was telling you how many were sold, so we would use this to find our revenue. If we have 2 points, can we write the equation of the line between those? Okay. So, slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we get negative 2 over 2,000 or negative 1 over 1,000. Then what do we do? Okay. So my y, let's just take this one, equals m times x plus b so our b equals 20. Alright, these, the 13 and the 15, those weren't the revenue, those were the price we are charging for our books, right? So what we have right now is our price equation. We usually use a lowercase p, so our price is negative 1 over 1,000 x plus 20. All right, revenue is price times quantity. So revenue is x times p of x getting rid of thousand x squared plus 20x. You guys all with me here? So now we are asking for the maximum revenue. So how would I maximize this? Derivative. Oh wait, I didn't ask for maximum revenue on this one, did I? I asked for maximum profit. Sorry. We need profit first before we do our derivative. Profit is revenue minus cost so my revenue equation minus the cost equation that we had at the very beginning. So profit is negative 1/1000 x squared plus 12x minus 10,000. And now we want to maximize that, so we do the derivative of this. And set that equal to 0. So then to answer the question, it wanted to know how many copies and what should be the price. So X is the number of copies. And to get our price, we plug the 6,000 into our price equation. So negative 1/1000 times 6,000 plus 20 is,
Wait, what? What are we plugging this into?
price.
That's cool.
Get a price.
That's what I got. I got 14. What do you do
All right.
at 8th hour?
Pre-calc, I took
Continue.
I don't know why I went back, but I took college algebra, so I'm basically just backtracking at this point.
Wait, so you took college algebra and now you're taking pre-calc?
Just so I stay in a math setting.
Put your 4 chairs on the